Picture a realm where the impossible becomes possible, where the very fabric of reality bends and twists in ways that defy our everyday experience. Imagine a world where tiny particles can exist in two places simultaneously, where the mere act of looking at something fundamentally changes its behavior. Welcome to the strange and captivating universe of quantum mechanics. The world of the infinitely small holds secrets that would make even the most imaginative science fiction writer pause in wonder. When scientists first peered into this microscopic realm in the early 20th century, they discovered a reality so bizarre that even Albert Einstein struggled to accept it. This is a place where cats can be both alive and dead, where particles communicate instantly across vast distances, and where uncertainty isn't just a state of mind, it's a fundamental property of nature itself. In this video, we'll embark on an extraordinary journey into the foundations of quantum physics. We'll explore how this revolutionary science has completely transformed our understanding of the universe, pushing the boundaries of what we once thought possible. You'll discover why the rules that govern our everyday world, the classical physics we learned in school, break down completely when we venture into the quantum realm. We'll unravel mysteries that have puzzled the greatest minds in science for over a century. From the famous double-slit experiment that reveals the wave-particle duality of matter, to the mind-bending concept of quantum entanglement that Einstein called spooky action at distance, we'll explore it all in terms that everyone can understand. But before we dive into this fascinating world of quantum weirdness, make sure to hit that like button and subscribe to Exploring the Universe. By joining our community, you'll never miss out on our latest videos about the wonders of astronomy and science. Together, we'll explore the greatest mysteries of our cosmos, from the smallest quantum particles to the largest structures in the universe. Turn on notifications by clicking the bell icon and get ready to have your mind blown as we venture into a realm where the rules of everyday reality no longer apply. Welcome to the quantum revolution. Let's start with the big question. What exactly is quantum mechanics? At its heart, it's the science that explores how matter and energy behave in the tiniest scales imaginable, the world of atoms and even smaller particles. But don't let this simple definition fool you. The quantum world is a place where our everyday intuitions completely break down. Think about throwing a tennis ball. You can predict exactly where it will land using classical physics. The same laws that helped us understand planetary motion and send rockets to space. These are the comfortable, predictable rules we're all familiar with. But when we zoom in to the size of atoms and their components, something remarkable happens. These familiar rules simply stop working. In this microscopic realm, particles can tunnel through solid walls, like a ghost passing through a barrier. Imagine throwing that same tennis ball at a wall, and occasionally it just passes right through. While this sounds impossible in our everyday world, it happens all the time in the quantum world. In fact, this very phenomenon is what makes the sun shine. Hydrogen atoms in the sun's core quantum tunnel through barriers that classical physics says they could never cross. The story of quantum mechanics began in the early 20th century when scientists like Max Planck, Niels Bohr, and Werner Heisenberg discovered that the atomic world doesn't play by the same rulebook as our visible world. It was a revelation that shook the foundations of physics and led to some of the most heated debates in scientific history. Even Albert Einstein, despite helping lay the groundwork for quantum theory, famously struggled with some of its stranger implications until the end of his life. Today, quantum mechanics isn't just a fascinating theory, it's the foundation of modern technology. Every smartphone contains billions of transistors that work because of quantum effects. MRI machines in hospitals, laser devices, and even the LED lights in your home, they all exist because we understood and harnessed the strange rules of the quantum world. Here's something to ponder. Have you ever wondered why the microscopic world seems so bizarre? What aspects of quantum physics intrigue you the most? Share your thoughts in the comments below. Perhaps it's the idea that particles can be in multiple places at once, or maybe it's the notion that observing something can change its very nature. Remember, even the most accomplished physicists admit that quantum mechanics is profoundly strange. As the famous physicist Richard Feynman once said, if you think you understand quantum mechanics, you don't understand quantum mechanics. Now, so don't feel bad if it seems mind-bending. You're in good company. Now let's explore one of the most mind-bending concepts in quantum mechanics, wave-particle duality. Imagine you're watching ocean waves crash against rocks. You can clearly see the waves moving through the water. Now imagine throwing pebbles into a pond. You see distinct particles creating ripples. In our everyday world, something is either a wave or a particle. But in the quantum world, things get wonderfully weird. In the quantum realm, particles like electrons can actually behave as both waves and particles simultaneously. Yes, you heard that right. The same thing can be both a wave and a particle at the same time. This isn't science fiction. It's a fundamental aspect of our universe that scientists have proven time and time again. The most famous demonstration of this bizarre behavior is the double-slit experiment, first performed with light by Thomas Young back in 1801. But the real magic happened when scientists started doing this experiment with electrons and other particles. Here's how it works. Imagine shooting individual electrons, one at a time, through two parallel slits in a barrier. Common sense tells us each electron should go through one slit or the other, creating two distinct lines on the detector behind the barrier. But that's not what happens at all. Instead, the electrons create an interference pattern, exactly like waves would do. It's as if each individual electron somehow went through both slits at once and interfered with itself. Even more bizarre, if we try to watch which slit each electron goes through, the interference pattern disappears and the electrons start behaving like ordinary particles again. It's almost as if the particles know they're being watched. This experiment was so revolutionary that it shook the foundations of physics. When scientists first observed this behavior, they could hardly believe their eyes. Even Albert Einstein, one of the greatest minds in physics, found it deeply troubling. Though it's worth noting that Einstein's famous quote about spooky action at a distance was actually about quantum entanglement, another fascinating quantum phenomenon. He was equally puzzled by wave-particle duality. The implications of this discovery are profound. It suggests that the very nature of reality depends on how we observe it. Richard Feynman, another brilliant physicist, once said that this experiment contains the central mystery of quantum mechanics. He went so far as to say that nobody can really explain how it works. We can only observe and describe what happens. Today, this principle isn't just a curiosity in physics laboratories. We use it in electron microscopes that can see individual atoms, in solar cells that convert light into electricity, and it's fundamental to understanding how atoms hold together. Every time you use a smartphone or computer, you're using devices that work because of our understanding of wave-particle duality. Think about it. The device you're using to watch this video right now exists because particles can somehow be waves at the same time. Isn't it amazing how the strangest aspects of nature often turn out to be the most useful? The quantum world might seem bizarre, but it's very much real, and it's everywhere around us, working its mysterious magic in ways we're still trying to fully understand. Let's dive into one of the most fascinating principles in quantum mechanics, discovered by a young Werner Heisenberg in 1927 while working at Niels Bohr's Institute in Copenhagen. The story goes that Heisenberg had this breakthrough during a late-night walk through a park, contemplating one of the deepest mysteries of the quantum world. The uncertainty principle, as it came to be known, tells us something remarkable about the nature of reality itself. There's a fundamental limit to how much we can know about certain properties of particles. Specifically, we can never know both the exact position and velocity of a particle at the same time. The more precisely we measure one, the more uncertain the other becomes. Now, you might think this is just a limitation of our measuring tools, but it's actually much more profound than that. It's not that we're not clever enough to measure both properties accurately. The universe itself prevents us from doing so. It's a fundamental law of nature, as basic as gravity or the speed of light. Think about trying to locate a car driving in complete darkness. To see where the car is, you need to shine a light on it. But here's the catch. The very act of shining that light will affect the car's movement, even if ever so slightly. In our everyday world, this effect is negligible, but in the quantum world, it becomes crucial. The tools we use to observe actually change what we're trying to observe. Here's another way to think about it. Imagine trying to catch a soap bubble without popping it. The gentler you try to be, the less sure you are about exactly where you're touching it. If you try to be more precise about the location, you'll inevitably pop the bubble. This is similar to what happens when we try to measure quantum particles. Heisenberg himself expressed this profound insight beautifully when he said, "What we observe is not nature itself, but nature exposed to our method of questioning." This quote reveals a deep truth about quantum mechanics. The observer and the observed are inexplicably linked. The implications of this principle shook the scientific world to its core. It challenged the very notion of scientific determinism that had dominated physics since the time of Newton. Even Einstein was troubled by it, famously declaring, "God does not play dice with the universe." To which Niels Bohr cleverly replied, "Einstein, stop telling God what to do." The uncertainty principle isn't just a philosophical curiosity, it has real-world applications. It's crucial in designing electronic devices, in cryptography, and even explains why atoms don't collapse in on themselves. The electrons in atoms exist in a kind of quantum cloud of probability, rather than following precise orbits, and this uncertainty quite literally holds matter together. Perhaps the most fascinating aspect of Heisenberg's discovery is how it changed our understanding of reality itself. We had to accept that the universe isn't like a giant clockwork mechanism where everything is precisely determined. Instead, there's an inherent fuzziness to reality at its smallest scales, a fundamental limit to what we can know. This principle reminds us of something profound. Sometimes, the more we try to pin down and control nature, the more it slips through our fingers. In accepting this uncertainty, we've ironically gained a deeper understanding of how the universe works. It's a beautiful paradox that lies at the heart of quantum mechanics. Let's explore one of the most magical aspects of quantum mechanics, superposition. Imagine flipping a coin. While it's spinning in the air, before you catch it and look at it, is it heads or tails? In our everyday world, we'd say it's one or the other. We just don't know which yet. But in the quantum world, something far more extraordinary happens. In the quantum realm, particles can actually exist in multiple states simultaneously, not just two, but potentially infinite states all at once. It's as if that spinning coin is literally both heads and tails at the same time, not just because we don't know which it is, but because it genuinely exists in both states until someone observes it. This isn't just theoretical physics. We're actually putting this bizarre property to work in revolutionary ways. Enter the quantum computer, perhaps the most exciting application of superposition. While a classical computer bit can only be either 0 or 1, a quantum bit or qubit can be 0 and 1 simultaneously thanks to superposition. This might sound like a small difference, but it's transformative. Imagine trying to solve a complex maze. A classical computer would need to try each path one at a time, which could take thousands or even millions of years for particularly complex problems. A quantum computer, using superposition, can explore all possible paths simultaneously. This is why quantum computers have the potential to solve problems that would be practically impossible for even our most powerful classical supercomputers. Scientists are already using quantum computers to tackle incredibly complex challenges, from designing new medicines to optimizing financial markets and even helping in the fight against climate change. The technology is still in its early stages, but the potential is mind-boggling. Problems that would take traditional computers longer than the age of the universe to solve could potentially be cracked by quantum computers in minutes. Here's a fascinating historical tidbit. When Erwin Schrödinger first described quantum superposition in the 1920s, even he found it hard to accept. That's why he created his famous thought experiment about a cat that could be both alive and dead simultaneously. He was trying to show how absurd quantum mechanics seemed. Little did he know that what he considered absurd would become one of the most powerful tools in modern technology. Now here's something fun to think about. If you could use quantum superposition in your daily life, what would you do with it? Imagine being able to try every possible answer on a test simultaneously, or being in multiple places at once. While we can't do these things in our macroscopic world, it's fascinating to think about the possibilities. Speaking of possibilities, if you're enjoying this mind-bending journey through quantum mechanics, why not join our community of science enthusiasts? Hit that like button and subscribe to Exploring the Universe. We're building a space where curiosity and wonder come together, where we can explore the strangest and most fascinating aspects of our universe. And here's a question for you. What aspect of quantum physics has surprised you the most so far? Is it the fact that particles can exist in multiple states at once? Or perhaps how we're using this strange property to build revolutionary computers? Share your thoughts in the comments below. I'd love to hear what blows your mind about the quantum world. Remember, every time you think you've got quantum mechanics figured out, it reveals another layer of mystery. As the great physicist Richard Feynman once said, nature isn't classical, darn it, and if you want to make a simulation of nature, you'd better make it quantum mechanical. Now, let's dive into one of the most mind-blowing concepts in quantum mechanics, quantum entanglement. Picture this: two particles born together in a single quantum event become deeply connected. No matter how far apart they are, whether they're across the room or on opposite sides of the universe, they remain linked in a way that defies everything we know about space and time. Change the state of one, and the other instantly changes too. It's as if they're sharing a secret language that transcends distance. Here's a simple analogy to help wrap your head around it. Imagine you have two magical coins. You toss them into the air, and no matter where they land, even if one is on Earth and the other on a distant planet, they always land on the same side. Heads or tails, they're perfectly synchronized. That's quantum entanglement in a nutshell. It's like the universe has its own version of cosmic twins. Now here's where it gets even more fascinating. When Einstein first encountered this idea, he was so baffled that he called it spooky action at a distance. He couldn't wrap his head around how two particles could communicate faster than the speed of light, which seemed to violate the rules of physics as he understood them. In fact, he thought it was proof that quantum mechanics was incomplete. But here's the twist. Decades of experiments have shown that entanglement is very real. It's not a flaw in the theory, it's a fundamental feature of our universe. Let's take a step back into history for a moment. In the 1930s, Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, proposed a thought experiment to challenge quantum mechanics. They argued that if entanglement were real, it would mean that information could travel faster than light, which they believed was impossible. This became known as the EPR paradox, named after their initials. For years, this paradox haunted the scientific community. Was quantum mechanics truly incomplete, or was there something even stranger at play? The answer came in the 1960s, when physicist John Bell developed a mathematical test to determine whether entanglement was real or just a quirk of the theory. Decades later, experiments based on Bell's work confirmed that entanglement isn't just real. It's one of the most robust phenomena in nature. It's as if the universe itself is woven together by invisible threads connecting particles across vast distances. But what does this mean for us today? Well, quantum entanglement isn't just a scientific curiosity. It's the foundation of some of the most cutting-edge technologies. Quantum communication, for example, uses entangled particles to create ultra-secure networks where information can't be intercepted without being detected. And in the world of quantum computing, entanglement allows qubits to work together in ways that could solve problems far beyond the reach of classical computers. Here's something to ponder. If particles can be instantaneously connected across any distance, what does that say about the nature of reality? Are we all somehow connected in ways we can't yet understand? It's questions like these that make quantum mechanics not just a science, but a journey into the deepest mysteries of existence. So what do you think? Does the idea of quantum entanglement blow your mind, or does it make you wonder what other secrets the universe is hiding? Share your thoughts in the comments below. I'd love to hear what you find most fascinating about this strange and beautiful phenomenon. And remember, every time we think we've got the universe figured out, it throws us a curveball. As the great physicist Richard Feynman once said, the universe is not only stranger than we imagine, it's stranger than we can imagine. Now, let's talk about something truly exciting. How the strange and mysterious world of quantum mechanics is shaping the technology we use every day. You might think quantum physics is just a bunch of abstract theories, but the truth is, it's already all around us, powering some of the most groundbreaking inventions of the modern age. Let's start with something you're probably using right now, your smartphone. Inside that little device are billions of transistors, the tiny switches that make all the magic happen. And guess what? Transistors work because of quantum mechanics. Without our understanding of how electrons behave at the quantum level, we wouldn't have computers, the internet, or even the ability to watch this video. It's quantum physics in action, right in the palm of your hand. Then there's the laser, another quantum marvel. Lasers are everywhere, from barcode scanners at the grocery store to the fiber optic cables that carry the internet across the globe. Even the DVDs and Blu-rays you might have used back in the day rely on laser technology. And let's not forget about medicine. MRI machines, which help doctors see inside our bodies, work because of quantum mechanics. They use the quantum properties of atoms to create detailed images that save lives every day. But what's even more exciting is what's coming next. Quantum computers, for example, are poised to revolutionize the world as we know it. Unlike classical computers that use bits, which can be either 0 or 1, quantum computers use qubits, which can be 0, 1, or both at the same time, thanks to quantum superposition. This means they can solve certain problems exponentially faster than even the most powerful supercomputers today. Imagine a future where quantum computers help us design new medicines by simulating complex molecular interactions, or where they optimize global supply chains to reduce waste and save resources. They could even crack encryption codes that are currently unbreakable, leading to entirely new forms of secure communication. And in the field of artificial intelligence, quantum computing could unlock capabilities we can't even imagine yet. But here's the thing, quantum mechanics is still full of mysteries. Even the great physicist Richard Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." And that's part of what makes it so fascinating. Every time we think we've got it figured out, it surprises us with something new. Let's take a moment to appreciate the journey. In the early 20th century, scientists like Max Planck and Niels Bohr were just beginning to unravel the secrets of the quantum world. They had no idea that their discoveries would one day lead to technologies that would transform society. It's a reminder that curiosity and exploration can lead to incredible things. So what do you think? Are you excited about the possibilities of quantum technology? Imagine a world where diseases are cured faster, where we can solve climate change, or where we can explore the universe in ways we never thought possible. The future is full of potential, and quantum mechanics is leading the way. Remember, the universe is full of surprises, and quantum mechanics is proof that the more we learn, the more we realize how much we still have to discover. So keep asking questions, stay curious, and let's explore the quantum future together. Let me tell you about one of the most famous thought experiments in the history of science, Schrödinger's cat. It's a story that's equal parts fascinating, bizarre, and a little bit unsettling. Picture this: a cat, a box, and a quantum twist that will make you question everything you thought you knew about reality. The story begins in the 1930s with physicist Erwin Schrödinger. At the time, scientists were grappling with the strange implications of quantum mechanics, particularly the idea of superposition, the concept that particles can exist in multiple states at once until they're observed. To illustrate just how weird this idea was, Schrödinger came up with a thought experiment that's now known as Schrödinger's cat. Here's how it works. Imagine you have a cat inside a sealed box. Alongside the cat, there's a radioactive atom, a Geiger counter, a vial of poison, and a hammer. If the Geiger counter detects radiation, meaning the atom has decayed, the hammer will smash the vial, releasing the poison and killing the cat. But here's the catch. According to quantum mechanics, the atom exists in a superposition of decayed and not decayed until someone observes it. That means the cat, by extension, is also in a superposition of being both alive and dead at the same time. It's only when you open the box and look inside that the cat's fate is decided. Now, I know what you're thinking. How can a cat be both alive and dead at the same time? It sounds like something out of a science fiction novel. But that's exactly the point Schrödinger was trying to make. He wanted to show how absurd it seemed to apply the rules of the quantum world to something as large and complex as a living being. In his own words, he wasn't trying to say this could actually happen. He was highlighting how strange and counterintuitive quantum mechanics could be. But here's where it gets even more interesting. Schrödinger's cat isn't just a quirky thought experiment. It's a profound exploration of the role of the observer in quantum reality. It forces us to ask, does the act of observing something fundamentally change its state? And if so, what does that mean for our understanding of the universe? This idea has sparked endless debates among physicists and philosophers. Some argue that the cat's fate is determined by the observer, while others propose that multiple realities exist simultaneously, a concept known as the many worlds interpretation. In this view, opening the box doesn't collapse the cat's superposition into one state. Instead, it splits the universe into two branches, one where the cat is alive and one where it's dead. Now, here's a question for you. What do you think happens to the cat? Is it alive, dead, or both? Or does its fate depend on something deeper, like the nature of reality itself? I'd love to hear your thoughts in the comments below. Let's get a conversation going about one of the most mind-bending ideas in science. And here's something to ponder. Schrödinger himself wasn't entirely comfortable with the implications of his own thought experiment. He created it as a critique of the prevailing interpretation of quantum mechanics, but it ended up becoming a cornerstone of the field. It's a reminder that sometimes the most powerful ideas are the ones that challenge us to think in entirely new ways. So the next time you hear someone talking about Schrödinger's cat, remember that it's not just about a hypothetical feline in a box. It's about the nature of reality, the power of observation, and the endless mysteries of the quantum world. And who knows, maybe one day we'll finally understand what's really going on inside that box. Let's take a moment to dream about the future, a future shaped by the incredible possibilities of quantum mechanics. Imagine a world where the strange and mysterious rules of the quantum realm unlock technologies that seem like science fiction today. It's not just a pipe dream, it's a vision that scientists around the world are working toward right now. First, let's talk about energy. One of the biggest challenges we face as a species is finding clean, sustainable sources of energy. Quantum mechanics could hold the key. Imagine harnessing nuclear fusion, the process that powers the stars, right here on Earth. Quantum tunneling, a phenomenon where particles pass through barriers they shouldn't be able to, is already helping us understand how to make fusion reactors more efficient. If we succeed, we could have a nearly limitless source of clean energy, transforming the way we power our homes, cities, and industries. But that's just the beginning. Quantum mechanics could also revolutionize space travel. Right now, traveling to even the nearest stars would take thousands of years with our current technology. But what if we could bend the rules of space and time? Concepts like quantum entanglement and wormholes, theoretical shortcuts through space-time, could one day make interstellar travel not just possible but practical. Imagine hopping between stars as easily as we fly between continents today. It's a bold vision, but one that quantum physics makes plausible. And then, there's the idea of parallel universes. Yes, you heard that right. The many worlds interpretation of quantum mechanics suggests that every time a quantum event occurs, the universe splits into multiple branches, creating countless parallel realities. While we can't yet prove this theory, the implications are mind-blowing. What if we could somehow access these other universes? What would they be like? Could we learn from them, or even interact with them? It's a concept that pushes the boundaries of our imagination. Now, I know what you're thinking. This all sounds like something out of a sci-fi movie. But here's the thing, many of the technologies we take for granted today, like smartphones and the internet, would have seemed just as far-fetched a century ago. Quantum mechanics has already given us lasers, transistors, and MRI machines. Who's to say it won't give us even more incredible breakthroughs in the future? Let's take a step back and appreciate how far we've come. In the early 20th century, pioneers like Max Planck, Niels Bohr, and Werner Heisenberg were just beginning to unravel the mysteries of the quantum world. They had no idea that their discoveries would one day lead to technologies that would transform society. It's a reminder that curiosity and exploration can lead to incredible things. So what do you think the future holds? Are we on the brink of a quantum revolution that will change the world as we know it? Imagine a future where we've solved the energy crisis, where we can explore the stars, and where we've unlocked the secrets of parallel universes. It's a future full of potential, and quantum mechanics is leading the way. Remember, the universe is full of surprises, and quantum mechanics is proof that the more we learn, the more we realize how much we still have to discover. So keep dreaming big, stay curious, and let's explore the quantum future together. As we come to the end of our journey through the world of quantum mechanics, let's take a moment to reflect on what we've discovered. The quantum realm has shown us that the universe is far stranger and more wonderful than we ever imagined. It's a place where particles can be in two places at once, where observing something changes its behavior, and where the very fabric of reality seems to bend and twist in ways that defy our everyday intuition. Think about it. For centuries, we believed the universe operated like a giant clockwork machine, predictable and orderly, but quantum mechanics shattered that view. It revealed a universe that's fundamentally uncertain, where probabilities rule, and where the act of observation plays a crucial role in shaping reality. It's as if the universe itself is alive, constantly shifting and evolving in ways we're only beginning to understand. This revelation isn't just a scientific breakthrough, it's a profound reminder of our place in the cosmos. Quantum mechanics shows us that we're not just passive observers of the universe, we're active participants. Our very presence, our act of looking and measuring, influences the world around us. It's a humbling thought, isn't it? We're both incredibly small in the grand scheme of things and deeply connected to the fabric of reality. Let me share a story that illustrates this beautifully. In the early 20th century, when scientists first began to explore the quantum world, they were met with resistance and disbelief. Even Albert Einstein, one of the greatest minds in history, struggled to accept some of its implications. He famously said, "God does not play dice with the universe," expressing his discomfort with the inherent randomness of quantum mechanics. But as time went on, experiment after experiment confirmed that the quantum world really does play by its own rules, rules that challenge our understanding of reality itself. Yet here's the beautiful paradox. While quantum mechanics reveals a universe that's deeply strange, it also shows us how interconnected everything is. Particles can be entangled across vast distances, instantaneously affecting each other no matter how far apart they are. It's as if the universe is reminding us that we're all part of a single, intricate web of existence. This connection isn't just scientific, it's deeply human. Quantum mechanics teaches us to embrace uncertainty, to question our assumptions, and to remain open to the wonders of the unknown. It's a reminder that the universe is full of mysteries waiting to be uncovered, and that every discovery brings us closer to understanding our place in it. So, as we wrap up this exploration of quantum mechanics, I want to leave you with this thought. The universe is far more mysterious and marvelous than we can imagine. It challenges us to think differently, to dream bigger, and to remain curious about the endless possibilities that lie ahead. And so, we've reached the end of our journey through the fascinating world of quantum mechanics. Together, we've explored the strange and wonderful concepts that define this field, from wave-particle duality to quantum entanglement, from superposition to the uncertainty principle. We've seen how these ideas have revolutionized science and are shaping the future of technology in ways that were once unimaginable. Let's take a moment to reflect on what we've learned. Quantum mechanics has shown us that the universe is far more mysterious and complex than we ever thought. It's a realm where particles can exist in multiple states at once, where observing something changes its behavior, and where particles billions of miles apart can be instantaneously connected. These ideas challenge our intuition, but they also open up incredible possibilities for discovery and innovation. Think about it. Just over a century ago, scientists like Max Planck, Niels Bohr, and Albert Einstein were grappling with the first hints of quantum theory. They were trying to make sense of a world that didn't play by the rules of classical physics. Today, their work has given us technologies that define our modern world. Lasers, transistors, MRI machines, and even the beginnings of quantum computers. It's a testament to the power of curiosity and the relentless pursuit of knowledge. But here's the thing, we're just scratching the surface. Quantum mechanics teaches us that the universe is full of mysteries waiting to be uncovered. What lies beyond our current understanding? Are there parallel universes? Can we harness quantum entanglement for instant communication across the cosmos? Will quantum computers solve problems that seem impossible today? The answers to these questions are out there, waiting for the next generation of curious minds to discover them. So I want to ask you, what do you think is still out there waiting to be discovered? What aspect of the quantum world fascinates you the most? Is it the idea of parallel realities, the potential of quantum computing, or something else entirely? Share your thoughts in the comments below. I'd love to hear what sparks your curiosity. Before we wrap up, I want to thank you for joining me on this journey through the quantum realm. If you've enjoyed this exploration, don't forget to hit that like button and subscribe to Exploring the Universe. By joining our community, you'll never miss out on our latest adventures through the cosmos. From the tiniest particles to the vastness of space, we're here to explore it all together. And if you want even more cosmic curiosities, follow me on social media for updates, behind-the-scenes content, and more mind-blowing science. Share this video with your friends, and spark a conversation about the wonders of quantum mechanics. After all, the universe is too big and too fascinating to explore alone. Remember, the journey of discovery never ends. Every question we answer leads to new mysteries, and every discovery brings us closer to understanding the incredible universe we call home. So stay curious, keep exploring, and let's continue this adventure together. Until next time, keep looking up and wondering about the infinite possibilities of the cosmos. This is Exploring the Universe, signing off. See you in the next video.